Question 5 is a rectangular distribution question, so you can check your formula book to check that you know what the answers are going to be, and write down the expected value of x. Well, on a rectangular distribution, the expected value of x is just halfway between the two ends. We've got 0 at one end and b at the other, so halfway between them is b over 2. Expected value of x is simply b over 2, just the one mark for that. But now we've actually got to prove that the variance is this, and so we can't just look at our formula books and do it. We need to remember our formula for this, the expected value of x squared minus the expected value of x squared. So our first job is to find out what the expected value of x squared is. You'll remember that's the integral of x squared times the probability of x, times by 1 over b dx. And we're integrating that between 0 and b, here. So let's do that integral. X squared, power goes up to x to the 3, dividing by 3, and I've also got a b down here as well. So I've got x cubed over 3b, and that's going between 0 and b, isn't it? Let's stick that b in. So we've got b cubed over 3b. I'll write the takeaway 0, but obviously you don't need it. And cancelling a b there, we've got b squared over 3. So the expected value of x squared is b squared over 3. Let's put this in this formula now then. The variance of x is equal to the expected value of x squared minus the expected value of x squared. I'm getting that because I did it in part A earlier. B squared. Now, b over 2 all squared is b squared over 4. Tiny bit of fractions work then. 1/3, take away a quarter, is a 12th. So I've got b squared over 12 as my final answer. Part B asks us to actually use the rectangular distribution, and although you can integrate, it's much simpler just to draw a picture. So let's just draw this picture here. It starts down here at 0.1. It finishes up here at 0.1. And how high is it? It's 5 high. So this point here is 5. Now we're being asked to find out when it's the probability of the modulus of t being greater than 0.2. So, well, this bit here is 0.02. Let's go down here at minus 0.02. And what we're really trying to do is find out this area and this area. Well, it'd probably be simpler just to find out what this area here is. This area here, it's 0.04 wide and 5 high, so 0.04 times 5 is 0.2. We don't want that bit, we want the other bit, so 1 minus 0.2 gives the probability of 0.8 for the bit that we need.